Okay, so in this question, a small ring A of mass 1 by 2 kg is attached at one end of a light string, the other end of which is tied to a block B of mass 2m. The ring is free to move on horizontal surface, horizontal rod. Find the tension in the string when it becomes vertical. Okay, so here like we can see that ring is free to move, so obviously it will move in this direction, and that block it's moving in downward direction initially, right? So this is moving like this, like downward is moving and it's moving horizontally. So that is like somewhat they will move. Okay, so here, so first of all, like because we can see that on this system there's no net force acting in horizontal direction, right? This rod is smooth here. Okay, and vertical force mg is acting, so we cannot say like there's no external force acting in vertical direction, but we can say there's no external force acting in horizontal direction, so external force in horizontal direction is zero. So from there we can say that the momentum of the system of right will be conserved. So here we are applying the momentum, right? Or we can say momentum of center of mass is conserved. Is okay. So initially VCM is zero, right? So VCM is zero because the system was at rest. So the momentum of the system should be zero. So m1 v1 plus m2 v2 should be zero. So m1 is m, like the mass of the ring, and the velocity of this one, like we are assuming that is v1. Okay. When okay, so here like these are the velocities, like when the string becomes vertical. Okay, so when the string becomes vertical, so this is the rod here, so the string becomes vertical because this is the ring and the block will be somewhere here. So it has velocity v1 here, it has velocity v2 in this direction, right? Horizontally it will be, so mv1 minus 2m, that is the mass, into v2 equal to 0. So here we are getting one equation, the v1 equal to 2v2. Okay, so let's see where can we use this equation. Okay, next is the 2m block is moving down, right? So we can apply the work energy theorems because there is a displacement of 2m block. Okay, so the displacement is L. So applying work energy theorem, so work done by gravity is equal to change in kinetic energy here. Okay, so there is only external force acting on the system. So work done by gravity is like 2m into g into L is equal to, so when it comes to this position, the displacement is L, right? Changing energy, so half, so in when it comes here, so this block has velocity, the ring has velocity, so both have kinetic energies here, so half m v1 square, the kinetic energy of the ring, plus half 2m into v2 square, the kinetic energy of the block. So we'll put this v1 equal to 2v2 here, so we'll get 4v2 square, and this 4v2 square, and we have 2v2 square, so this is 6v2 square, 6mv2 square by 2, and left hand side we have 2mgl, and get cancelled here, this is 3, so v2 square we are getting as 2gl by 3, so that is v2 square. Okay, now we'll calculate. Okay, so like v1 will be written as 2gl by 3 with root, and v1 will be equal to 2 times v2, right? Okay, so let's keep it like this. Okay, now we need to find the tension when the string becomes vertical. So in this position we need to find tension. So in this case we have to focus on this block, and we want that the ring should be at rest. So here we will use the relative concept. Okay, because like once we assume that the ring is at rest, so we can say that this block has a velocity which is perpendicular to its distance, right? The distance between the points, right? So this will be the velocity. So velocity of block with respect to ring, if we'll write velocity of block with respect to ring, that will be v2 and v1, so that will be like v2 plus v1, right? And in this direction. So once we calculate the velocity, so the ring is at rest and the v block has a velocity v1 plus v2 in this direction. So at this instant we can say that this block is kind of moving in circle. Okay, so this because the ring comes to rest, Okay, so rings comes first, so this one can be assumed as a center. So this is the velocity of block with respect to ring v1 plus v2 in this direction. Now we'll apply the force equation. So the force, net force towards the center, so there's the tension here and there's a 2 mg and there's a like velocity. So that force equation is net force towards the center, so T minus 2 mg is equal to mv square by r, which is 2m by l into v square. V square is this one. Okay, so v2 plus v1, basically like v1 is like nothing but 2v2, so it is 3v2, right? So we are using 3v2 here, so mv square, so like we are using this one, right? So it is v1 plus v2, so 3v2 square will come here. Okay, so mv square by l, right? So this is the velocity, so this is 9v2 square. V2 square is 2gl by 3, 2gl by 3. So we'll just solve it. 3 is a 9, so here we are getting 3 4 is 12, so T is equal to, so 2 mg will go there, so this is, we have 12 plus 2, so 14 mg we are getting, and the m value is given, which is 1 by 2, so from there T is equal to 7g, and that is the answer, the tension in the string at this instant. That's it.